In the previous video, we set up the biceps brachii muscle, and we learned how to, and we saw how to basically making it attached and slide not only on top of the mummy geometry, but also on top of the brachialis muscle. But we connected the fibers of the biceps muscle only over only to the flexing sensor, right? And the problem with that is that the biceps muscle it is also driven by the action of the supination of the wrist. Okay, so what we need to do now is that we have to create this sensor. So that goes from here to here, which as the distance reduces for this sensor, it means that we are supinating the wrist of the arm, which means that we need to activate the fibers too. So let's create the sensor first. So let's create first the locator, distance locator. This will be called L, arm, supination, sorry, wrist supination. Okay, great. Now with this selected, we create the sensor and we name the sensor L, wrist supination. And now we can go and define the range. So to define the range, again, this will be 0 activation at 9,214, great. But then we have to see what the distance will be in this case. And this will be our, our input max, which will be 3.5, okay. Cool, so we see the activation happening. Now, let's select the muscle and let's go to the node editor here. So here we can look at the ADN muscle solver. We can open it and we can see, we can look at, here, the activation. Cool, that is coming from here, from the sensor, which was the flexing sensor. Let's select this new sensor for the wrist supination. Okay. Yeah. Sorry. 1 second. Let me select it from here. Don't know. Here, cool, and let's add it here. So in this case, I also want to add the activation distance to the activation of the biceps brachii. So I'm going to create a new node that we have in Adonis, which is called AdnActivation, and it enables us to create a stack of activation inputs. So here we have value, and then we need another one here, which will be where are you? Here. I need the activation distance. Where are you? Activation distance. Here, sorry. I was struggling a little bit finding it. Cool. Which goes to AdnActivation. Now, the thing is that the AdnActivation node allows us to to select the different operators, so we can multiply, we can add, we can divide, etc. In this case, we are going to add. So we will get the two activations, add them together, and then clump them between 0 and 1, so that the output value will never be greater than 1, and then we connect it this way, okay? So what this will do, let's have a look immediately. Let's go to 981 so that we can start computing this. So if I do this, you can see that the biceps is activating, right? So just by the action of the supination. And at the same time, if I flex the arm, it's also going to activate because of the action of the arm flexing. Now, when I go through the animation, once it's flexed, I won't be able to see much happening anymore, right? Because I'm already at an activation that is 1. So we need to modulate the activation from the flexing so that then only the supination is added. Let's go back to the node editor. Let's get these flex input, and let's add a remap value, okay? That is going to get us from a range of 0 and 1 to a range of 0 and 0.5, sorry. So we're using, because flexing is actually the secondary action of the biceps brachii, we are going to use 0.5 there. And now let's have a look at the result of this. And we probably have to use even less. So let's go 0.3. Okay. Yeah, here you go. So we have a first activation happening, and then we have the supination contributing to the activation on top of it, okay? And you can play with all of these parameters depending on the final result that you want to achieve, obviously on your rig. Cool, so we have all of this. So probably what is left to do is basically set up all of the other sensors and set up all of the other muscles before we get into setting up the fascia.